All right, folks, we're going to work on our next section of notes. This one is on average mass number. Hopefully, after we've already done the lab activity, this should make a lot of sense. But we're going to do an example. So let me share my screen. This one I'm not going to do with PowerPoint. I'm actually just going to use, we're just going to show you the notes. And here they are. Wonderful. Okay, so we are in this section, the average mass number section right here. And so we are going to calculate the average mass number for bromine. So this is the scenario we've been given. We have 100 atoms of bromine. 51 of them are the isotope bromine 79, and 49 are the isotope bromine 81. So 51% of the atoms are bromine 79, and 49% are bromine 81. All right, so we want to figure out what is the average mass number. So the way I think about this is a weighted average kind of problem, but really there's 100 atoms. So if we're going to do an average, we know is equal to, like, the average, in this case, average mass. Let's do this way. We know that average, it's the sum of all masses divided by the number of atoms in this case, right? So it's always you add up all the numbers, you divide them by the number. Pretty simple kind of calculations, a basic average situation. So if I were to do this, I need to sum up all of the masses. So I would need to do 51. The actual mass of each individual bromine atom is 79, but there's 51 of them. So I'd have to do 79 plus 79 plus 79 plus 79. Okay, yeah, I'm not going to do that. That's insanity. Let's simplify it. I'm going to do 51 times 79. So what we've essentially done there is we've added up all of these bromine 79s. Now we need to add up the 49 bromine 81s. Again, I don't want to do 81 plus 81 plus 81. Like, that's insane. So let's just now add. There's 49, and they have a mass of 81. So that's the weighted average part. Now all we have to do is divide that by the total number of atoms, which is, okay. If you said 2, the answer, no. This is a very common mistake. It is not 2. There are 2 types of atoms. There are 2 isotopes of bromine, the bromine 81 and the bromine 79. However, the total number of atoms is 100. So we need to divide by 100. Now, all we got to do is put it in the calculator. You don't have to have a TI 80, you don't have to have a fancy TI, but I just happen to love mine. So let's go through and we'll do the math. Sorry, if you haven't figured out, my camera's pointing this way and then my setup is over here. It's awkward, but it'll work. All right, so 51 times 79. You know, I'm gonna put that in parentheses. I don't think PEMDAS requires it. I don't think we have to, but I'm just gonna do it anyway because I like it. Why not? You don't have to. Your calculator can figure this out. Depending on what type of calculator you are, though, be careful. You might have to do them as 2 separate things, then add them together, you know. And let's hit enter, and then we'll divide it by 100. Okay. So that is going to be 79.98. Technically, there is a unit for this, and it's AMUs, but we're not going to worry about it. So our average atomic mass is 79.98. Let's compare that to the periodic table. Let's see, bromine. Bromine is right here, and you can see it's 79.90. So that's pretty close. I think we pretty much got it. Maybe there's a third isotope that's a little, or maybe these ratios are just slightly off, but that's pretty gosh darn close. So I would believe that. So again, this this method is how we end up with the numbers on the periodic table. That's why we have decimal points. And it's not, you know, this is interesting too, now that I look at this, and it makes sense. Looking at the periodic table, you would think that bromine, the most common isotope, would be bromine 80, but it isn't. Like, there really isn't such a thing as bromine 80, or if it is, it's super, super unstable. It's really that it's about 50-50 bromine 79 and bromine 81. So that's kind of interesting. It's almost misleading in a way, but you know, if you have a big sample of bromine, it doesn't really matter. Bromine, by the way, it's as an element, it's a liquid at room temperature, and it's kind of this dark red orange color. It's also like the other halogens, it's pretty toxic to humans. I was working with bromine once in organic chemistry in college, and I accidentally inhaled some. And yeah, that's really bad. I didn't inhale very much because it just really stung like inside my nasal passages and like my sinuses. I could feel it. It was really gross. It felt bad for like an hour. If I had really hurt myself, if I had really breathed some in, it could have been a big, big problem. So lab safety, super important. Don't ever breathe things in because you don't know what you're going to breathe in. All right. So that's average mass number. Again, there will be other videos that will help with this to help to do. Hopefully the lab activity really helped. There are 2 problems in your unit packet. If you get your unit packet and you are on page 4, it's these 2 problems on the bottom. I put these in a weird order. I'm sorry about that. We're going to do these 2 sections next. I know they're on top. We can just skip around a little. And we also haven't done the very bottom of page 3 yet either, but it's okay. We'll skip right back in. It'll be fine. All right. So that's what I've got for you for right now. We've got a couple more sections of notes, and I'll see you all for those in a bit. Toodles!